let's get into SQL. Now, the first thing I'm going to say is that I still sometimes out of habit still call this SQL. You can tell that I have a lot of habits around databases and I just cannot break free of them. Like I've been doing this for a decade. The correct way to say this is SQL and MySQL, but it's SQL Server, and you write SQL for SQL Server. I still call it SQL because I was around a bunch of people that called it SQL, so I apologize. I really mean SQL, but when I say SQL, usually SQL is associated with like the Microsoft stack and like Microsoft SQL Server. So when I say SQL, if you hear me say SQL, I will try and stop myself, but obviously I was not successful with records versus documents. Anyway, just like NoSQL is kind of a dumb marketing term, so is SQL databases. When I say SQL databases, what I really mean is relational databases. And you also see that sometimes abbreviated as RDBMS, which I think is Relational Database Management System, I think is what that stands for. But again, that means an SQL-based database or a relational database. It's also important to remember that not all relational databases use SQL, and not all non-relational databases don't use SQL. But again, I'm trying to use the most common terminology here to hopefully like demystify some of this stuff. So when you see SQL database, you can kind of loosely associate or even strongly associate that with relational database in your head. Hopefully that's as clear as mud, because marketing is dumb. I don't know why these people still try and confuse us more, but let's talk about relational databases. For the rest of the time, I'm going to try and use relational database because that's actually probably the closest thing to what I mean. So what is a relational database? The best thing to think about with relational databases is Excel, right? Excel or numbers or some sort of spreadsheet. That is like the easiest picture. It's like a table of data. And notice that the name of a collection in a relational database is called a table. That is no coincidence. Yeah. So it's good to think of this as rows and columns. In fact, those are terms that I'll use as rows and columns. One of the things with the relational database is it has a defined and very structured schema. Whereas if you remember in Mongo, we were writing to our collection and we just added the owner field on the fly. That's very easy to do in MongoDB, and it's not very easy to do in SQL, because SQL is like, you need to tell me about all of these fields before you can give them to me. If you try and write something that doesn't exist, it just won't let you. So what we would have to do, you actually have to issue an entire statement called an alter table statement, which you don't want to do. Alter tables are very expensive. As in, like we used to do alter tables when I worked at Reddit, it would literally take down like Reddit for us to do that. So we were very cautious to not alter our tables very much. So a big thing up front is defining your schema. Here's the secret power of relational databases, is that they're very good at describing relations, right? Whereas with MongoDB, you don't want to ever have like this collection refer to this collection over here. That's not a good idea. With MongoDB, one of the things that you don't want to do is you don't want to have one collection refer to another collection in general, right? That's a very expensive thing for you to say, join these two collections based on this one field, right? In general with MongoDB, when you're architecting this type of data, you want all of the like data to live together, and MongoDB provides you with a lot of tools to be able to do that. Now, I was actually talking to my friend who is a director at MongoDB, and he's like, you can do it, it's possible, and in certain situations it makes sense to do that with MongoDB, but I still hold to the rule that if you're doing joins, you're doing MongoDB incorrectly. With SQL, that's like a core component of how SQL actually works, is that you want to have data that relates to each other. So you're going to have multiple different tables, and those tables are going to refer to each other. The example that we're going to do today is we're basically going to create a message board. And with that message board, we're going to have a collection of, or a table of boards that are going to refer to a table of contents. Sorry, table of comments. It's hard to say that way. A table of comments, right? And those are going to be two separate tables that are going to refer to each other based on IDs. And we're going to do joins, and that's a big power of what SQL databases can do. So that's why it's called relational databases, is because it's very oriented to the idea of data relating to each other. So what is SQL? Why do I keep referring to this dumb acronym? I hate acronyms. Why do we have this one? SQL stands for Structured Query Language, which I had to look up. It was one of those things I never knew. I just always knew what SQL was. And it's a powerful query language. Whereas in MongoDB, we were using JSON and JavaScript to write queries to query MongoDB, SQL is what you're going to use instead of JavaScript to query this database. So it's a very kind of structured query language. That's useful to say out loud. It's a language that is structured that you use to query databases. So if you use this kind of grammar, you'll be telling the database how and where and to do these kind of queries, and we'll get into that. Whereas there's not a ton of document-based databases out there. Like if you're going to talk about a document-based database, you're going to be talking about MongoDB most of the time. That is definitely not the case for SQL. With SQL, there is a lot of different types of databases. I chose Postgres because I think that's kind of the accepted, I don't say accepted, it is one of the most used databases for JavaScript developers. And it has a lot of features that I think JavaScript developers will find interesting, and it's just well used today. Beyond that, it's just my favorite, right? Like it's the one that I would choose today if I was going to go write a new application. Now, the elephant in the room, that is pun not intended, but also kind of funny. The elephant in the room would be the mascot for Postgres is an elephant. That's why that's a dumb joke. Would be MySQL. MySQL is the other relational open source database that gets a ton of usage. And I actually, my first job and my second job, I wrote a lot of MySQL queries. It's great. It scales enormously. Facebook is famously based heavily on MySQL, so it obviously it does well. MySQL is also backed by Oracle, so obviously they know a thing or two about databases, so it's well supported. It's a very good choice today as well. Google and Netflix are all two other very big utilizers of MySQL. Some people don't want to be tied to Oracle, and so another group of the old core committers of MySQL formed a new database called MariaDB. MariaDB is meant to be a drop-in replacement for MySQL, so they are largely compatible. It's just more open source. It's not tied to a big company, and it's another very well-used database as well. So those are kind of like the ones that people mostly think about. The other one to kind of just mention is SQLite. This one's a little bit different. It's meant to be very small. It actually doesn't even have any net code or anything like that. It's generally something you're going to drop into like an IoT device. My Mac is currently running SQLite. Everyone's Mac is running SQLite. Like it ships in a lot of things. It's very small. It's very performant. It's meant to kind of be that kind of thing. Generally not used in web dev scenarios. I would not recommend it for web development scenarios, but it is a very simple one to get started with. You can always keep that in mind. And then the other one are like the big corporate players like SQL Server, Oracle, IBM DB2. These are kind of like the big corporate databases. They're very expensive. Like typically you're going to sign like a very large corporate contract to use one of these. I'm not going to tell you about them because I never use them and I never have used them, despite the fact that, like I said, my father literally worked on DB2. But they're out there as well. I'm sure some of your companies are using them. They're obviously good products.